This is an example of an AP Calc question that wants us to use cross-sectional areas to determine the volume of a given shape. So when we're doing cross-sectional areas, the volume of our cross-sectional area is going to come from finding the integral from a to b of whatever our area formula is dx. Looking back through the problem, what you'll see them telling us is that we've got this solid is our region bounded by the x-axis and this function right here. And then what we'll need to do now is find our area based on that. And they tell us that our area is the area of a square. So what we're looking at right now, you may not know the exact shape of that equation, but you know that it's some function that has to get bounded between it and the x-axis. And so kind of just give yourself a shape to work from. Even if it's not the right shape, it kind of tells you what you should be looking at. So that function and the x-axis here are creating a region that we have bounded. And what they're telling us by telling us about these cross sections that are perpendicular to the x-axis is that we're drawing one edge of a square comes from that edge right there. And so to find our area formula, we want to say, okay, I'm finding the area of a square. Well, the area of a square would be side times side because the side lengths are the same, or side squared is a way to think about it. And so this is my side right here. Wherever I might be along the x-axis, that height, that distance from here to here, that is what one side will be. And we find that length by just plugging into our square root function. So the area formula on this is going to be the square root of 1 minus 4x squared, that's what the side length is, squared. The nice thing here is when we square a square root, they cancel each other out, so we get 1 minus 4x squared. So putting that into our volume formula over here, we know we're going to have the integral, and now we know what our area formula is. It was the area of a square, which is side times side, and so we found that formula here. This is 1 minus 4x squared dx. Now what we need to do is we need to go find our bounds on this. Well, to find the bounds, we may not, again, know exactly what the shape is, but we know that to finish up being bounded, that my square root graph is going to need to run into the x-axis. So to find out when that happens, I just need to do a little algebra problem. I want to know when does the square root of 1 minus 4x squared, when does that equal 0? Because that's what the x-axis is. And if I solve that, that's going to get me what my bounds are for this. So I'll start off by squaring my square root to cancel that out. I'll square both sides of that. Squaring the square root is going to get me 1 minus 4x squared equals 0. And then we're just going to keep solving this to get x by itself. Whenever I can make things positive, I'm gonna. So I'll move that 4x squared over to the other side. I get 1 equals 4x squared. Then you'll go ahead and divide by 4, divide by 4. We get 1/4 equals x squared. And now we'll square root both sides of this to cancel out the squared. When you square root something, when you apply the square root, you get the plus minus of that number. So this is plus or minus the square root of 1/4. So we're really looking at two answers here. We have x equals negative square root of 1/4, and we also have x equals positive square root of 1/4. To clean that up a little further, just remember that when you're dealing with roots and division, you can break that up. So this is actually the square root of 1 over the square root of 4. So we would end up with x equals negative 1/2. The square root of 1 is 1, the square root of 4 is 2. So that tells me that over here, this is really negative 1/2, wherever that's happening. And then on the other side, I get the square root of 1 over the square root of 4, which is going to get me just x equals 1/2. And so that's my other side. Again, I don't need to know the shape of the graph. I just need to know where it runs into that x-axis. So now I can come back over here and I can put my bounds into this integral. So this is negative 1/2 to positive 1/2. Now I have an antiderivative. Now I have a definite integral that I can solve to get my final answer. So we'll find this out by following our power rule. taking the antiderivative of 1, the antiderivative of a number by itself, it always gains a letter back. So this would be 1x minus, doing my power rule on this, I would add 1 to the power and divide by the new power. So adding 1 to the power gets me x to the third, divide by the new power, and then I'm going to evaluate that from x equals negative 1/2 to x equals 1/2. From there, to keep finishing this up, this is what I just call top minus bottom. To get a number out of this, we're going to take the top value, plug it into our equation, and subtract off the bottom value plugged into the equation. So working our way through this, this would be equal to, and then I would have 1, plugging in the top value, that'd be 1/2, minus 4. If we think about this, this is really 4/3. You can slide that 4/3 to the front, and then times 1/2 to the third. Then minus, I'm going to have 1 times, and now I'm plugging in the bottom value, so negative 1/2, and then that's minus 4/3 times negative 1/2 to the third. And then we'll just keep cleaning this up a little bit at a time. I get 1 minus 1/2 up in the front is going to get me 1/2 minus 4/3, and then 1/2 to the third is going to give me 1/8. And as I do this stuff, especially when I can kind of see that the numbers are going to be similar, I usually don't try to combine it all into one fraction until I absolutely have to, just because a lot of times things are going to cancel out or add up nice and cleanly. So on this piece, I can cancel the 4, cancel the 8, and that's going to leave me a 2. So up front, I now have 1/2 minus 1 on top, and then 2 times 3 is going to get me 6 on bottom. Then I'm going to subtract off of that, and I do the same work on this. So I come over here, I get 1 times 1/2. Remember, it's minus this whole chunk, so it's minus parentheses. That's one of the key steps to this whole problem. A lot of people drop that parenthesis, and they'll get their signs wrong as they come through here. So then we've got minus 4/3, and then negative 1/2 to the third is going to get me negative 1/8. And again, I can clean this up a little bit. That 4 and that 4 would cancel out to be a 2. I get a negative here is going to end up giving me a positive. So this is going to be 1/2, and then negative will give me plus a 1 on top, and then the 2 times 3 is the 1/6 on bottom. From here, the reason that parentheses is so important is because it's minus this whole thing. So I'm going to distribute this 1/2 back into everybody here. Oops, and I forgot. Back up top here, this is what happens when you don't write as clean as you should. That's a negative 1/2 that I plugged in there. So that's going to be a negative 1/2 there and a negative 1/2 right there. So I would have 1/2 minus 1/6, distributing that negative. That's a negative is going to give me a positive 1/2. And then the negative times 1/6 is going to give me a negative 1/6. And here's why I kind of like to keep these things separate, because I have a 1/2 plus 1/2 is going to get me 1, and a negative 1/6 and a negative 1/6, that's going to get me negative 2/6. So I haven't had to find a common denominator yet to put these fractions together. I can just keep kind of working through it. So then this 2/6, I'm going to cancel out a 2, cancel out a 2. That's going to give me a 1/3. So now I'm looking at 1 minus 1/3, which again, I don't really need to do that common denominator game. I know that 1 minus 1/3 is going to get me 2/3, and that's going to be my final answer. So volumes of a solid, right, when we're doing cross-sectional areas, you got to create your area equation, and that's usually, you've got this length here is going to be coming from the equation they give you. Set up your area formula, find those bounds, and then from there it's just going to be a definite integral problem to the end. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.